Everyone. Ooh, there we go. Hello, everyone. Welcome to the Human Behavior and Dimensions panel. So as a sociologist, I'm an assistant professor of sociology here at Colorado State, and I also work with the Colorado School of Public Health, the School for Global Environmental Sustainability, and the Water Center. I am thrilled to be moderating this panel because one of the big questions, as most of you know, right, is the people problem, or the people question. We can have all of the technical solutions and policy approaches, but what really matters is the social systems and how people, I shouldn't say what really matters, what can mess with that, right, are the people involved and the social systems onto which we're putting these policies. So I am thrilled today to have three very different perspectives on this issue on our panel. And when we had talked as a panel, we had decided that one of the most effective ways of talking about all of these different perspectives and disciplinary expertise that this panel brings is to let them present to you in a narrative form what they're working on and the ways in which they're looking at human dimensions. So we are going to hear from each of the panelists for about 10 minutes. They're going to give us a very riveting presentation from each one. No pressure. No pressure. And we're just going to go down the road, and then we will have about 10 minutes at the end for questions. So be thinking about what you would like to ask these gentlemen. So just so that we know who everyone is, and then I'll give you a little bit of an introduction for each speaker. You, of course, have more extended bios in your program, but we have Bas van Rooyen, Dave Siplett, and Richard Caperton. Bas is going to talk to us first, so I'll tell you a little bit about his background. Bas is a project scientist for the National Center for Atmospheric Research and the Climate and Global Dynamics Lab. He works with the Integrated Assessment Modeling Group in the National Center for Atmospheric Research in Boulder. So he came up today to visit us from the Denver-Boulder area. And he's also a research scientist at the Boston University Pardee Center for the Study of the Longer Range Future. So, you know, no small problems here. Bas is very interested in working on and modeling future scenarios for impacts, adaptation, and vulnerability indicators for climate change and how we will be responding to climate change. So he's going to talk to us a little bit about that today. Thank you, Bas.
Thank you, and thanks for the invitation, and it's great to be here. And I'm really happy to be able to actually introduce you a little bit in 10 minutes, very quickly, to my world, which is maybe a little bit different from what you've seen, but underlies many of the global graphs that you see these 2 days on energy use and on emissions and mitigation. And so my world is global modeling of energy and economy for the very long term. And I'll then talk about what we actually do with human behavior in that context. But first, a little bit about the tools that we use. We call those integrated assessment models, which basically means that they're economic models that you look at more than just the economy. They also look at energy and at land use and climate, greenhouse gas emissions, climate change, how that impacts everything. We run those for the very long term, up to 2100. So that is sort of tricky business. It's not just going out for the next 2 or 3 or 4 years. It's really far into the future. And in the global resolution, spatially it's really rough. You're talking about models that divide the world up in just 10 regions, or maybe up to 30 if they're most granular. But so you're not at the level of single states, not sometimes individual countries, of course, but it's really rough. And the emphasis of each of these tools that we use come from really different backgrounds. So some are really focused on the energy system. Others stem from economic principles and economic modeling, and also the paradigms that you use in this framework. Some are trying to describe the world sort of the best understanding that we have, simulate the world as we know it, and others are really optimizing and try to find the best solution that you could choose for the future. But of course, that will never pan out that way because that's not how the world works. So what are these models used for? We make global projections at the global level, hardly any time at the national level. And so for energy use, energy demand, what will people use energy for, and how much will they demand, and how will it be supplied? Land use change, greenhouse gas emissions, air pollution into the future, but also a very strong link, increasingly actually, with developing countries and with the Millennium Development Goals that were lined out in the panel before, by linking this whole description of the economy, the energy, and the land use system with actual development problems. And so it's not only making projections, it's only looking at, well, trade-offs and synergies, right? What if you have a policy that goes in this direction? What does it do to something else? What do energy policies actually mean for land use, or the other way around? And can you have, and are those always trade-offs, or can you have synergies between the two? And so now go into behavior and how humans and human behavior plays a role in this. Traditionally, these models come from economic backgrounds where the households and the people that you model are behaving very cost optimizing or very rational, with rational rules in a way. And that might actually be not a very bad description for how people behave on the level of a country, right? Not every individual of us might behave the most rational way we could, but if you aggregate all of us across the room, we come maybe reasonably close. And then if we move on to behavior and energy demand, you have approaches where you go up from the bottom and you say, well, everybody wants to have certain appliances in its home, and how would we aggregate those across the country, and how does that actually add up? The other way is to go from the top down and say, well, we have a certain amount of economic activity in our country, how much energy use does come with that, right? And those are really fundamentally different approaches, and each of those has really different opportunities to deal with more granularity, bring in more behavior, bring in more diversity between people and households. And so I'm going to actually tell you about 2 experiments instead of the 3 that I noted on this slide. I'm going to tell you a little bit about experiments where people with these global models in the past 5 or 10 years have been looking how can we bring more real-world behavior into these models, and what does it actually mean for the result of our work. And so one experiment is going to be on household energy use in developing countries, and the second one is going to be on transport vehicle choice. The first is from a model that I worked with in the Netherlands, where we looked at developing countries and said, well, you know, the models that we have developed over the past decades are all really representative for industrialized regions. We don't include many of the dynamics that are important in developing countries. And so what would be a good way to go about that? And what are the most important differences between households in developing countries? And so, well, of course, you have the urban and rural difference, which is much larger in developing countries than it is here for us. But also income distribution is a much more important issue. And the difference between poor and rich households is much more influential on energy use. And so we included that in our work, looking at ownerships of appliances and fuel choices for cooking. And so if you look here, for instance, for India, these are graphs for on the left for urban, on the right for rural households. And then from left to right, we go from poorer to richer households. And these are the appliances that people have. And so you see that the order of appliances is generally the same across urban and rural households, but people take the first thing that they buy once they have access to electricity is a fan, then a television, then a refrigerator, and then you have the cooling equipment down the road when people get really more affluent. Bringing in those dynamics actually changes your projections for the future, because people buy really different sort of appliances and put them on the demand network once they grow more affluent. Cooking fuel, another example. Now here, rural is on the left, urban is on the right, and we have income quintiles, so 20% of the poorest to 20% of the richest, from left to right. In green, people using fuel wood for cooking, which is rural, of course, enormously common. And then to the right, you see shifts when people grow richer, that they switch to kerosene and LPG for cooking. And the way to go about this is to say, well, apparently there are costs, or there are disadvantage costs that actually push out those fuel wood options, right? People that are richer, it is still the most cheap option for all of us to go out, gather some wood, and cook on a wood stove, because it wouldn't cost you anything. However, we value our time a little bit different than a very poor person that has no other choice. We don't want to go out, gather wood, and have all that pollution in our house. We value our time and our health actually higher, and so that's why we make other choices. And putting a monetary value to those disadvantages that some of the fuels have actually helps you simulating how people would start behaving differently when they actually grow more affluent, and how that behavior is also different across different household types. Now, looking at what this actually means, let's only look at the bottom graphs here and only look at the two right, Latin America and Middle East and Africa. This is from a paper that I recently did, evaluating how different types of global models actually deal with developing countries. And in here, you see the colored bars are for different scenarios, different ranges of how models project energy use for developing countries. And there are two models that did a lot of work actually on improving the household side and the dynamics that I just explained. Those are the message model and the image models. And they are consistently at the high side of this range of future projections across their peers. And so that is sort of one takeaway here, is that if you go from optimal behavior to more real world behavior, you might actually end up with descriptions that have much higher energy use projections for the future than you would have otherwise from the optimal side. Am I going over my time or no? Okay. So, okay. Second example is a little tricky to present because it's not my own work. It's actually a collaboration between the Message Group in Vienna and UC Davis, of which we had a speaker on the last panel. That's on transport behavior and vehicle choice. And if you go from there, from a single household to multiple households, to 27 households in this case, where you go over 3 dimensions, like people that buy vehicles have choices in their attitude towards technology. So we have early adopters, early majorities, late majority people that are slower in adopting technologies. We have different settlements where people live, urban, suburban, or rural. And we have different driving behavior. So frequent drivers, average drivers, and modest drivers. All those characteristics of people play a role in how they actually, when they buy new vehicles and what kind of vehicles they want to obtain. Some of them are just their driving characteristics, the amount of miles that they drive. That determines, of course, a lot of what you do. The other things are really behavioral, right? Like adopting behavior. And so here you see what that meant when they included this kind of behavior into their model. On the top, you see a scenario into the future where you see in brown fossil fuel internal combustion engines, and then a switch over time towards gray, which is our electric vehicles. And that is the homogeneous, if you have only a single household making a single choice with optimistic or optimized behavior. Then you go to the middle, you see on the left, if you only introduced the heterogeneity between households, so the amount of miles they drive, you still have a similar result. If you go to the right of that graph, you see that if you introduce the behavior, how risk-averse people are, how much people actually care about range anxiety, the amount of charging points there are, you see a transition all of a sudden from the brown to the green, which is biofuels in an internal combustion engine, and people become much more risk-averse towards electrical vehicles. If you combine the two, you go to the bottom graph, actually, where you see that the behavior of people and their attitude towards new technologies actually dominates the total result if you combine the heterogeneity among households and their technology preferences. Now this, of course, has consequences for your global abatement results, right? Here we see 2 mitigation curves of how much CO2 you can mitigate against a certain cost. On the right, the dark line blue is actually the one that you would have with a single representative household. Now, if we introduce all that heterogeneity and risk-averse behavior of people, you actually go to the left, which means that at a certain given level of a carbon price, you would have less mitigation because of the behavior of people. Now, there are some really, really big caveats to this research, right? Because, first of all, it's incredibly data intensive. And if you do this on the global level, you need to have the data for all the world regions that you include. You cannot go to this level of better granularity, more behavioral modeling for only one out of your 10 regions, because then you get an enormous imbalance in the result of your model between a single region and the rest of the world. The other thing with the data is, of course, that the data is present day, or best case, probably the data is 5 or 10 years old by the time it gets to your desk, which makes your results really, really dependent on the present day preferences of people with respect to appliances that people obtain in developing countries, but also with respect to vehicle choice. The risk-averse behavior of people towards electric vehicles might be very realistic in a survey that was done 5 or 10 years ago. But if you would do that same survey now, you might have different results, right? And so do you keep those behavioral parameters the same for the whole century, which they actually did in this study that I just showed, where people stay as risk-averse as they are at the moment? Or do you start making your own assumptions, basically, about how people might change their behavior into the future, which is also fairly tricky to do for a scientist. There are, of course, middle ways to go about that and have sort of informed assumptions about how people might change in the future, depending on, for instance, how many electric vehicles are actually on the road. But still, you know, it's always an assumption. And then, you know, you create a lot of, there's a lot of potentially creating false detail in your projections, right? Because you go out with many different household types, you're not projecting for 2050 or 2080 how a poor household in India is actually going to behave. This is not a forecast of a poor person in 2080 in India. This is a scoping exercise where you say, well, based on all the data and knowledge that we have now, how do we think the future will evolve? And the future might evolve completely differently than we think based on our current knowledge and current data, of course. So, coming to a conclusion here, actually, that introducing human dimensions and behavior in this world is only in its very early stages. But the results indicate that if you do it in the models, you actually have higher projections of energy use or higher emissions and more expensive mitigation due to the caveats, actually, that I just mentioned. Thank you.
Thank you so much, Bas, giving us a little bit of insight into these models that we see, right, that can at times, I think, seem a little bit lack transparency or seem a bit overwhelming. So I'm going to move down the panel, so if you have questions for Bas, please jot them down and we will get them at the end. We're going to transition now to Dave Siplett. Dave is an assistant professor of environmental studies at University of Colorado in Boulder. He's a sociologist focused on global governance, environmental inequality, and climate justice. And if you're interested in climate justice issues, he's the lead author on a really excellent book called Power in a Warming World, The New Global Politics of Climate Change and the Remaking of Environmental Inequality from MIT Press. So Dave today is going to talk to us a little bit about, he's going to give us kind of that sociological perspective of inequality. When we're talking about these human behavior issues, right, and we're talking about macro level modeling issues when we're looking at climate, Bas brought up that we have a lot of complications there, right? One of these complications is modeling households, as you said, right? And predicting that behavior, predicting in the future, because so much of what those intervening variables have to do with inequality and differences within countries, differences between countries. And Dave focuses a bit on that. In particular, he looks at equity issues related to energy, both at the local and global level. And he's really interested in the tensions between ecological sustainability and environmental and social equity as we move forward with climate mitigation policies. So without further delay, here's Dave.
Great. Thank you very much. So as Stephanie mentioned, I'm kind of giving the more kind of structural side of this and looking pretty big picture. This is a bit of some preliminary analysis that I'm doing for a project that I'm just beginning. And really I'm just going to raise a question and start digging in a little bit. So looking at this idea of sustainable energy for all and potential, at least looking at one potential tension in that goal. Just to start, I want to give a shout out to Jill Harrison. She's a sociologist at CU Boulder, and we wrote an article together that's informed some of this presentation that I'll talk about today. I also want to give a shout out to the Just Transition Collaborative, which is a group that I'm part of in Boulder. And I see Magnolia Landaposas, if you could put up your hand, and Michelle Gabrielle Parrish, are you here too? We are working in Boulder to ensure that the city and county planning around climate and energy is grounded in equity, right? That social justice is a key part of that in terms of the workforce, in terms of how benefits and burdens are created in this transition. And I'm not going to talk about the local level today, I'm going to go global, but please come talk to me or Magnolia after if you want to hear more about what we're doing in Boulder. So how many people here have had some idea of the Sustainable Development Goals? Have kind of some. All right, so these are big goals, ambitious, where we want to go as a global community. And so goal 7 is ensure access to affordable, reliable, sustainable, and modern energy for all, right? Which sounds pretty straightforward. I think we heard in the last panel that having basic energy conditions ties to all these other conditions of health and well-being, and we're a long way from this goal. So we're also seeing now, this is kind of the way this is being framed across development organizations. So organizations like the World Bank, within the United Nations, other development banks, are all kind of taking on this idea of sustainable energy for all, right? It's no longer okay that we're just gonna either focus just on sustainability or that we're going to allow for people who lack access to energy to develop coal, oil, gas, fossil fuel resources. And estimates for how we might achieve this goal globally range from about 30 billion to 130 billion a year. So costs are pretty high to do it, not in comparison to how much we spend on things like military, but still generally in terms of development spending, pretty high. So the question I want to raise, given kind of limited resources, at least what we've put to date into these types of problems, and relatively high costs, will international sustainability efforts, on the one hand, be compatible with those for energy access? Okay, sustainability on one hand, energy access. And so there's lots of ways we can talk about sustainability, but I'm going to focus here on climate change as kind of maybe the one that gets the most attention right now at the international level. There's lots of these different kinds of charts when we can see that the red looks at if we want to keep global temperature, average global temperature rise to 1.5 degrees would be the red, and the blue is 2 degrees. 106 countries came together in Paris in the climate negotiations and said we need to keep temperatures below 1.5 degrees rise because a lot of island nations go underwater at that point, right? So having a temperature that's allowing for more temperature rise than that is inherently unjust. No matter how we look at it, this is a very steep hill, right? And every year it gets a little steeper. I don't know if anyone ever, I'm in Boulder, and Magnolia is the steepest hill in Boulder. I used to ride my bike up it. I can't really do that anymore. But we get this gets a little steeper every year, and you can see it actually goes below 0, which means we actually need to be removing carbon from the atmosphere in some way when we get to around 2050 or so. So these are very ambitious in terms of what we need to achieve. We could have a long talk about how dire this is, but it's certainly a major challenge. On the energy poverty side, in terms of access, we also have some major challenges. We currently have about 1 billion people that have no access to electricity. Where are those people? Most of them are in sub-Saharan Africa, and also we have a lot in India. We've made some big progress, as you could see in the last chart, and this might be a little hard to read, but the takeaway from this here is that when we're talking about how we've made up the progress in bringing electrification to communities that don't have it, a lot of it's been done through fossil fuels, right? There's still not that much renewable energy that's providing for this shift, which creates a problem. So if we want to think about the sustainable energy for all, we can think about it in a Venn diagram, right? On one hand, we have sustainability goals. We address climate change. We mitigate our impact by bringing renewable energy to places that don't have renewable energy. They're using fossil fuels, or we reduce the use of fossil fuels. On the other side, we have equity, which is, in this case, it's bringing electrification to people that don't have it. In the middle, we have a just transition, right? We have the ability for these two goals to come together, where we're increasing sustainability at the same time that we are bringing equity, right? We're dealing with energy poverty. So in terms of resources, if we're thinking about from development organizations of how should they spend their money, if we want to prioritize sustainability, they would want to ensure maximum environmental impact of those public resources. If they want to ensure equity, they want to ensure maximum equity impact of spending those resources. And when it comes to renewable energy, that means we want renewable energy funding to countries with the highest projected emissions, right? Or to regions or peoples where we're going to have the biggest mitigation gains. On the equity side, we're going to want to send it to those places that have the biggest, that currently lack electrification, right? That have the lowest rates of electrification. So the question is, are these two priorities likely to be compatible? And that's what I'm going to look about. So if we're going to look on the equity side, I'm going to start there. What's the current status? Who currently has the lowest electrification rates? So pretty clearly, it's sub-Saharan Africa, right? And when we match this to what are called the least developed countries, right? This is a bit old. It's actually 49 countries now. We say it's almost an exact match, right? That those countries that are the least developed in terms of there's 3 UN indicators on this, also had the least access to electricity, okay? And we can see that sub-Saharan Africa is where this problem is the greatest, and this is projected, right? This is hard to say, but it looks like India is more on track than sub-Saharan Africa by 2030 to provide electricity to people in rural areas. Right, so if we were a development agency, we might say the biggest challenge is really sub-Saharan Africa from an equity perspective. In terms of the mitigation side, in terms of sustainability, what's the biggest challenge? Well, it gets a little muddled in terms of where the biggest growth of emissions are. If we look here, we can see that Africa is a pretty significant slice, but we would need to dig in a little more. And I'm not going to dig totally in, but I want to show this. This is current emissions, right? And it's a map that is reconfigured to show where we have high emissions and where we have lower emissions. And we can see the least developed countries are in that skinny piece in the middle of Africa, right? Which means they have virtually no emissions in terms of the overall scale of the problem. They contribute less than 1% historically emissions, despite accounting for 12% of the global population. So the folks that are the most in need of electrification are also the lowest in terms of their pollution impact. We can also dig into this in per capita emissions, so per person emissions, right? Because countries like India look really significant if we want to look at the overall emissions to the problem, but India is still about 130th, 131st in the world in terms of per capita emissions, which is crazy, right? Because India is often villainized as much as the U.S., India, and China are really need to address climate change. But the fact is that most people in India still aren't contributing their fair share of emissions to this global hot tub in the sky of where we can put these emissions, right? They're still disadvantaged there. So we can also look at this not just at the country level, but in terms of an urban-rural divide, right? So there's a study from 2015 that pointed to, one, at a country level, even more than wealth, the degree of urbanization, it matters most in terms of carbon emissions. So if you're a highly urbanized country, you're more likely to have higher carbon emissions. But we can also look at the subnational level, and those cities are likely to have much higher emissions than rural areas. And importantly, when we're actually talking about those folks that don't have access to any electricity, this tends to be the most costly and often in rural areas in order to meet that last bit of the 10 or 15% are missing electricity. And that might change with different technologies, but it tends to be pretty costly. So coming back to this, are these compatible priorities? And I would argue that there's a challenge here that needs to be discussed, and that these tensions and trade-offs, we can't just pretend they don't exist, because what's likely to happen is that those actors that tend to be more influential, and say from a US standpoint, maybe we're concerned most, maybe not our government, but maybe we're concerned most about climate change as a public more than the electrification of rural Africa, because it's something that influences us. It's part of meeting global public good. So USAID or the World Bank, we might be more inclined to support newly industrialized countries and major cities through our development assistance in supporting renewable energy for taking off there, while we might neglect the equity concerns, even though we're talking about it a lot, because we're looking at trade-offs, right? So on one hand, we would look at newly industrialized countries and urban areas, the other in terms of the LDCs, least developed countries, and rural areas. And so just raising, kind of concluding, looking at some discussion points that I'd like to raise. One is that in scholarship and discussion, what Jill Harris and I called for is a critical just transition, that we can't just pretend that sustainability and equity goals always go hand in hand, especially if we want to really lift up the equity. We have to acknowledge how we ensure that equity is prioritized when sustainability has historically, sustainability efforts have historically neglected the equity side of this equation. Second, we can't assume that prioritizing the distribution of public goods for greenhouse gas mitigation will likely support the electrification for all goal without having a real targeted strategy around that. And so some research questions that I'm starting to dig into are how are development agencies that are using this sustainable energy for all, how are they actually conceptualizing their prioritization of these issues, and how are they actually in practice going about distributing funding in relationship to these two distinct goals that sometimes can overlap but sometimes do not. And moreover, if we continue to see areas like sub-Saharan Africa, and particularly rural areas, being neglected, what sorts of opportunities are there really to catalyze a just transition in those areas with currently limited funding coming from the international domain? How can we scale up international funding? And then what sort of grassroots or kind of domestic efforts can be prioritized to move this forward? Thank you.
Thank you so much, David, for that. A lot to chew on between these two presentations. Last, we have Richard Caperton. Richard is the Director of National Policy and Regulatory Affairs for Oracle Utilities. Richard has quite a bit of experience in terms of looking at behavioral science and use data and trying to use that to get people to reduce their consumption of energy. So he's looking at things from kind of the behavioral perspective for energy efficiency and energy use, and really getting people to picture something that we oftentimes have a big gap between what we do on a daily basis and what we're actually using, right? We don't really know that as energy users most of the time. To give you a little bit more information on Richard, he leads Oracle's state regulatory work across Eastern North America, as well as any engagements with the federal government, including Congress, administrative agencies, and the Federal Energy Regulatory Commission. So you wear many hats, Richard, right? So he's going to give us a little bit of background on this, and then we will have some time for audience questions.
All right, pressure's on. Those are two really cool presentations so far, and just really interesting stuff that I was learning. So I was glad to be here and learn from that. I'm going to talk about how we actually shape behavior change at the household level. It's going to be focused on the United States, North America. Happy to talk about implications for the rest of the world if people have questions about it, but most of our work on this particular subject is in the United States and Canada. So let me just describe, so This is a legal statement that I don't fully understand that we have to put in here all the time. I think it means that nothing here is actually like contractually obligates me to product delivery or something. You should read it. So Oracle Utilities, you've all heard of Oracle, 140,000 plus people working at a software company building databases and things that, 100% of the Fortune 100 use Oracle products. There's a division of Oracle called Oracle Utilities that focuses on software for electric, water, and gas utilities. We're recognized by numerous industry consultants as leaders on a number of products, and we work with about 2,600 utilities around the world. That's all the large American utilities as well as water utilities in Pakistan. So it really does span the full scope of what a utility looks like. And this is just to give you a description or some picture of the types of things we build. On the left, you start with things like how a utility plans their assets, plans their asset investments, how they manage the grid, how they integrate data from their meters, so billing systems, meter reading systems, how they actually track customer data, and then on the far right is how they engage with their customers, including demand-side management or behavioral energy efficiency. Oracle Utilities acquired Opower, a company I worked for until a year ago, last year, to fill out this whole portfolio, and Opower was responsible for that part on the right, the customer engagement part and demand-side management. When I say demand-side management, what I really mean here is behavioral demand-side management. So it's not hardware in houses, it's giving people the information they need to change how they use energy. And the specific thing that we do that I'm going to talk about today is behavioral energy efficiency, which is about giving customers the tools they need to manage their energy use, including getting them motivated to change their energy use and then giving them advice on how to do it. So it all comes out of it actually all comes out of a field of economics and psychology called behavioral science or behavioral economics that recognizes that people may not always be economically rational actors. There are other things going on that shape their behavior. And in the energy sector, this really dates to a foundational study that took place in California after the California energy crisis in the early 2000s. You'll remember, of course, rolling blackouts at that time, insufficient power, the end of deregulation in California. So it was a real fundamental issue in California. And some behavioral scientists realized that one thing we needed to do is get people to use less energy. And we could probably do that with behavioral science, but they wanted to figure out how or prove out that that would work. And so these two researchers got their grad students to go onto people's property, trespass on their property most likely, and hang doorknob hangers on their doors that told them that you would save energy if you ran a fan instead of using your air conditioner, which is factually true. But then they also gave people a motivating message. And some people got a message that they would save money. Some people got a message that they would help the environment. And then some people got a message about being a good citizen and helping to keep the lights on. Keep in mind, this is after rolling blackouts. So actually, let's do a quick survey of which of these probably made the most difference. What about saving money? What about the environment? There's some optimist folks out there. I'm not calling on anybody, so feel free to raise your hands. And what about like being a good citizen? Yeah, so actually none of these had any impact whatsoever. Total waste. But the good news is there was a fourth message, which is that your neighbors are doing this. And if you let people know that their neighbors are doing it and create that peer comparison, that what we call normative messaging, those people actually reduce their energy consumption, which is a remarkable lesson. And so the co-founders of Opower took this study and turned it into a business. And you can't do that with grad students hanging doorknob hangers on people's houses and going up to read their meter. So what they did was they did two things. One is they invented something that they call the home energy report. And then they built the software that would power the home energy report or create the home energy report. And this is a two-sided piece of paper that we mail on behalf of utilities to utility customers. It includes some behavioral science like normative messaging, telling people actually comparing them to similar households based on household size, household energy usage, how many people are in the house, and telling them if they're above average or below average users, giving them some data analytics on their usage. Like these people, you see it's very small, but last summer you used 30% more electricity on cooling than your neighbors, so giving people some useful insights. Using loss language, which is more impactful than the prospect of gaining money, so you risk losing money if you don't do these things. And then finally, creating some peer proof, giving people options to reduce energy and telling them like 20 people in your neighborhood have done this already. We started doing that with paper. Now we do it over email and the web as well. And it has driven remarkable results. This is really exciting that it's not just feel good, it's not just giving people information, but actually measuring the impact of that information. And this is the exciting stuff. In 10 years, we have helped people save more than 16 terawatt hours of energy. So the Hoover Dam generates about 4 terawatt hours of energy a year. So right now we're doing more per year than the Hoover Dam. In those 10 years, we've helped people save more than $2 billion on their energy bills, electric and gas bills. And we now send that home energy report to 15 million households across North America. We send it to several 100,000 households in Colorado. Customers of both Xcel and Black Hills Energy get it. There may be some others too, but at least those two utilities are customers of ours. And then we can also talk a little bit about, we can go a little deeper into the savings. We see that the savings last. So if you start sending people home energy reports and keep doing it, people will continue to respond to it. They don't get tired of it and stop saving energy. And the really interesting thing is that demographics aren't destiny here. All sorts of people save energy. And so we can break that down a little bit too. And we looked at energy savings by income level, and we see that all people save at about the same rate. I think these are all statistically equivalent. Energy savings by age, young people and older people all save at about the same rate. Number of residents in the house. Big households save as much as or smaller households. But the one thing that does matter is that people who are already efficient save less energy when they get this information. And that intuitively makes sense because they have less energy to save. So big users are bigger savers. We measure all that with a randomized control trial, just like drug trials, where we separate a population of customers into 2 different groups. One of them is a treatment group that gets the information, and one is a control group that doesn't get anything. We keep that control group as small as possible so that we do serve as many people as possible, but we do want that control group to give the most accurate measurement. And then you just measure the difference in the usage between the 2 sets of customers. So what's interesting with that is that you can measure not just the change in energy usage, but you can measure all sorts of other things once you set up the randomized control trial. And so we look at things, everything that a utility wants and everything that a utility customer wants. They want to save energy, but they also want to be happier customers. They want more digital engagement. They want to increase participation across the entire demand-side management portfolio at the utility. And we see an impact on all of those. We measure this through what we call a customer engagement sentiment tracker. This is, as far as we can tell, the world's 2nd biggest survey of utility customers behind J.D. Power and Associates. And we just call utility customers and ask them a number of questions about their utility, about their energy consumption, about how they respond to the home energy report. And we see a few things. One is that people really they respond positively to the home energy report. They remember it, they read it, they share it with their neighbors. That is remarkable. When was the last time you showed your electric bill to your neighbor? So that's interesting. They put it on their refrigerator, and then they actually, 77% of people report taking some action. Now, of course, that's self-reported, so take it with a grain of salt a little bit, but that's pretty positive that people at least feel like that's how they're supposed to respond. And then the next thing is around customer sentiment, and you see people are really much happier with their utility when they get it. Things like, my utility wants to help me save money. It has a measurable impact on that, which is exciting. And then finally, it's not just about getting people to turn off the lights. Part of this is that people are actually much more engaged with energy efficiency and their energy consumption, and so they're much more likely to take advantage of other utility programs. So utilities have a range of energy efficiency programs, home energy audits, for example. Those customers are 16% more likely to take advantage of a home energy audit when they get a home energy report from their utility. So a number of exciting outcomes here. And we think that it's part of a modern utility experience, and it's what customers are looking for. And we're happy with the results and looking forward to doing more with it. Thank you.
Wonderful. Thank you, everyone. Thank you, Boss and David and Richard, for your fascinating presentations. We have about 10 minutes for questions. I'm going to scurry around, but there are also microphones scattered around. So who would like to ask the first question of our panelists? This is easy. We'll go right here.
It's a question about the utility tracking. Are you doing anything with blockchain in terms of the way that we measure utility bills and track ownership and that kind of stuff?
We should have a sidebar conversation about it. There's a much longer answer. Oracle is investing in blockchain. We still don't know what the exact uses are going to be in the utility sector, and I think that's a question that everybody has. We're looking at doing pilots with utilities and figuring out what the right use cases are, but it's definitely something that's very interesting for us, for the entire company, not just Oracle Utilities.
Okay. I'm really enjoying your presentations, and we are seeing in the Ukraine an approach of trying to sabotage electric grids and really have the impact of depriving their citizens of energy. And I've actually gotten together with a Ukraine group that came over to visit some sustainable homes here, and they were very interested in developing a sustainable approach so that the grids would not be as significant as a system of denying energy. And so how do your behavioral approaches relate to something like that? Because I wonder if this isn't something that we're going to see more of over time. And certainly the security discussions here suggested that. So I'd be interested in your thoughts and comments on that.
So not specific to Ukraine, but relevant to Ukraine. I think there are two things here. One is that you'll recall that people that use less energy save less energy with home energy reports. And that makes it really hard. You know, there's some fixed costs involved in printing a piece of paper and mailing it to somebody. It's hard to be cost effective in places that use very little energy. So that's a challenge that we have in developing countries. I continue to believe that the United States focuses on energy exports as a way of exerting political influence, especially natural gas exports, and we need to pair that with energy efficiency exports and talking with other countries about what we can do to help them reduce their energy demand and not just give them other energy alternatives. So it's good to know that people from Ukraine are coming over here to learn about that. I think that's exactly the right message.
Yeah. Again, a bit from the global perspective. There's two things. On the one hand, indeed, you know, as came up in the last panel, the grid is the greatest tool that we have for all of these. On the other hand, the moment you realize how incredibly vulnerable actually the grid is and how dependent we all are on it, that it can be an enormous impact once you start using it on national security issues for other countries. In these global long-term projections, we run them with really diverging scenarios on how the world cooperates or not, or is basically constantly on the brink of war or not. You can model wars, but you know, assuming that you go in that direction with lots of tensions, most of the assumptions that we've made so far are on how countries respond to that, how countries want to have all of their resources basically in their own country and produce their own energy instead of being dependent on others because it could be used against you. Taking it one step further, actually to households, is a very interesting thought in that respect, and seeing whether people would want to be off the grid because it's a vulnerable position to be in a world that is on the brink of of conflict all the time. Yeah.
Did you have anything you wanted to say, or I can take another question?
Yeah, I would just, I mean, maybe just to add that we do see the kind of reproduction of the same types of energy models around the world, and often those energy models reinforce a certain distribution of power within those societies, and I think it's important that we really reimagine how we can set up energy infrastructures, but also we really look at who's benefiting from the current systems and how that can be challenged.
So I am one of your hundreds of thousands of Excel customers that's using your report. And I will admit that when we get one that says that we are the most efficient, in the most efficient group, that I high-five my husband.
Good for you.
But I also, on occasion, am told that I am one of the least efficient in use. And frankly, although I pay attention to it, I frankly don't know what behaviors I'm exhibiting that puts me in one group or another. And so what is the next step in helping consumers understand exactly what it is that they are or are not doing that puts them in one category or another? And I think that that really applies to the other two panelists as well, you know, in terms of driving behavior. How do you get people to really understand what specifically they do or do not do that affects their impacts?
So believe it or not, we do make mistakes sometimes. So if you feel like you've actually got a mistake, let's talk about it and let's get that fixed. I think the bigger issue, though, is that we work with the information that we have. And we have varying degrees of information depending on what the customer has given us or what the utility has given us. And we have tools that we use to try to get more information to help us fine-tune the analysis we're doing for customers and the insights that we're giving for customers. So for example, if you were to go online and take the online energy audit and talk and submit some information about how your house is heated, that might help you get it might help you get more appropriate insights for you. It's something that we're always struggling with, is how to get access to more information that's appropriate and relevant without also overwhelming people with information. But congratulations being most efficient sometimes.
All right, I think we have time for one more quick question. We will get a youth perspective back here.
So Dave, you were talking about how that seventh objective is to obtain sustainable energy, but how do you propose we do that without retaliation from oil giants like BP?
You're on the spot there, huh, Dave?
Yeah, no,
That's a big question.
What are you doing for lunch? I mean, personally, I think that there will be retaliation, or there are very strong interests. There's a $30 trillion currently invested in known reserves that are on the books to extract, and where we have infrastructure set up to extract fossil fuel resources that we know will take us far beyond this 2-degree threshold, let alone a 1.5-degree threshold. So my own view is that any strategy of changing our energy system globally comes with conflict, and it comes with building citizen and political power that can challenge energy companies that have a strong stake in the existing system. Which isn't to say that that technologies aren't emerging that are cost competitive, and that really that from a market perspective, this isn't, we also won't see renewables come up, but they're not going to come up quick enough to deal with the climate change problem. We need power to push back.
All right, thank you, Dave. Thank you to our panelists once again, Boss, David, and Richard.